Hello everyone, this is Pravesh Malviya. So in the previous class we had a brief discussion about construction of DC machine. In that we discussed that the construction of DC motor and DC generator are nearly same, but the thing which is different in both construction is their enclosure. So in this lecture we'll be going to discuss about the main parts of DC machines. So there are various parts of the DC machine. They can be stationary or can be rotating type. So the parts are as magnetic frame, yoke, pole, field coil, armature core, armature winding, commutator, brushes, bearings, and shaft. So these are the main parts of DC machine. We'll find these parts in motor as well as in DC generator. So now we start with magnetic frame or yoke. So this is how a magnetic frame looks like. So what is it? It is actually the stationary part of the DC machine. And what are its functions? It supports the pole core, provides the mechanical protection to the inner part of the machine, and provide low reluctance path to the magnetic flux. Now, this is the stationary part of the DC machine. It's actually it's actually a protective cover for the inner circuit, for the inner parts of the machine. It also houses all the stationary parts of the DC machine. Coming to the next one, poles. So we are talking about the field poles. These are the stationary parts. Now these field poles, when we look at close to these field poles, we find that these field poles have two sections. This is the pole core. The upper region is the pole core, and the curved region down below is the pole shoe. So the pole core is basically provide strength and housing to the field winding, and pole shoe, the curved portion, spreads the magnetic flux over the outer periphery of the armature winding. So the pole has two parts itself, pole core and pole shoe. The entire unit is known as pole. So as I discussed that the pole has two functions. It supports the field exciting coil. It spread the magnetic flux over the armature periphery uniformly. That's why it is in a curve shape. And it has one more function, that is it increases the cross sectional area of magnetic circuit, and as a result the reluctance of the magnetic path is reduced. So now coming to the next part, that is the field coil. So in the previous slide we discussed about the field pole of the DC machine. Now the field pole is actually provides mechanical strength and housing accommodation to this electric circuit, that is the field winding of the circuit. When DC current is passed through this field coil, a flux is set up in entire core, and that flux, when links with the armature conductors, it produces torque in the entire rotor. Coming to the next one, that is the armature core. So the armature is actually the rotating part of the DC machine. So this is how an armature core looks like. Now we see that the armature core is made up of some metal, but it is not made up of a single metal piece. It is made up of thin sheets. Why? To reduce the eddy current losses. Now these slots, we see some slots in the armature here. These slots are to provide housing to the armature winding, and the center slot is for the shaft on which the entire rotor is mounted. So it is of cylindrical shape. It has two purposes. It houses the conductors in their slots. These are the slots here. And it provides easy path to the magnetic flux. Now coming to the next part, that is the armature winding. Now in the previous slide we saw that there are some slots in the armature section, outer periphery of the armature section. Now this is the winding, this is the rotor winding, which is slotted into the open slot of the armature winding. So this is the armature winding. Now armature winding in a DC machine can be of two types. It can be either be lap winding or it can be wave winding. So in lap winding, the number of parallel paths are equal to the number of poles, and in wave winding, the number of parallel paths are always equal to 2. So this is how the windings can be connected in lap or wave. Now coming to the next part, that is the commutator. Now the commutator is actually the main part, the heart of this DC machine. So here we see that this is the rotor, which is known as the armature. Now in this armature we find something, this part is known as the commutator. Now this commutator is having various segments, and those segments are actually electrically insulated from each other with the help of mica insulation. So these segments are insulated from each other, as well as they are insulated from the main shaft of the rotor. Now where these segments are actually connected, these segments are connected with the help of riser to the armature winding, which is the rotating electric circuit of the DC machine. So this is how actually a commutator look like. So we see here that these are the copper segments, and there are some slots over here. These are known as the riser. These risers are connected with the armature winding, and with the help of mica insulation, these are insulated from each other as well as from main shaft. So this is the commutator. Brush assembly. Now there is we saw that there is a rotating circuit, which is the armature circuit in a DC machine. So that rotating circuit should be connected to the external supply or external load in case of DC generator. So a rotating circuit cannot be connected easily with the external circuit. So for that we need to have brushes. So we see here that the commutator, which is the rotating part of the DC machine, is connected with these brushes. So these brushes are actually the stationary part of the DC machine, and these are actually pressurized on the outer periphery of the commutator segments. These brushes are actually made up of carbon and graphite mixture. So this is the actual diagram. Now we see that this is the commutator, and on the outer periphery of the commutator we see that these brushes are joined together. The brushes are actually made up of carbon and graphite mixture. Graphite is a conducting material, and carbon helps it to maintain its melting point at higher temperature. So this entire assembly is known as the brush assembly. This copper metal piece is the brush holder, and the black portion you see inside this holder is the brush. So with the help of brushes, we can connect the rotating circuit to the external circuit, and we can extract or insert the supply to the rotating circuit. And the last one is bearings and shafts. So as the DC motor or a generator is a rotating electric machines, so there will be some friction losses. Now to reduce those friction losses, we use bearings. Bearings can be roller bearing or ball bearing depending upon the size of the motor and the RPM. Now shaft. So the entire rotor is actually mounted over the shaft, and with the help of shaft we can extract the torque generated in the armature to the outer load. So this is all about the construction of the DC machine. The construction of DC machine is for DC motor and generator is nearly same, and the difference between motor and generator's construction is just their enclosure. So when we assemble all those parts together, a DC machine, a motor or generator looks like this. Here we see that on the end ring there are brushes mounted over there, which connects with these commutator segments, and that's the bearing. This entire frame is of cylindrical shape. This is the magnetic frame, and this is in between we see that this is the rotor armature circuit. And one thing we didn't discuss in the construction is its fan. So when the rotor rotates at high RPM, the fan also rotates with it. So why a fan is actually needed in a machine, in a rotating machine? So what happens, we see that we have two, at least two electric circuit. We have one on the rotor and another one which is stationary, the field winding. So these two electric circuit are when energized because of flow of current. So when current flow through any conductor in any winding, it results in I square R loss, which is in the form of heat. So if in continuous operation, if the temperature of the entire system is not maintained, that it can result into insulation failure. So to maintain the temperature in a certain limit, we use a fan unit that helps it's in ventilation. So this is all about the construction of DC machine. In case of any query, you can contact me anytime. Thanks for watching.